I just wanted to say thanks to everyone for joining me on my first ever YouTube live video. It was a little rough, but I think we got through it. So in this video, I wanted to just go through some different sensors and show how they're running on the flipper. All right, let's get started. Okay, so first up, we're going to look at this Java ring, which runs one-wire protocol. So we're going to I button read and connect it to the back of our flipper. And you can see it read the identifier of our Java ring. Okay, so we're going to go into I button and read. So this is the one wire. We're going to use the ground on the outside of the button and then the pin 17 one wire on the top of the button. And that's still able to read the device. Next up, we have the DS18B20 temperature sensor. So we go into I button and read, and we're going to take ground to our black, and we're going to take pin 17 to our yellow, and it read the identifier of our temperature sensor. Next in our GPIO demos, we're going to go into temperature sensor reader. We'll say add a sensor. We'll pick the DS18 series. Notice this time the GPIO is on pin 2. And we will connect the ground to the black, the yellow to pin 2 and hit scan. We got an address, so we can save that. And now it's reading the temperature of the room, 85. It's nice and warm in here. Next up is this GPS unit that uses USART. So we'll go into GPS and you can see the satellites it's picked and the latitude and longitude location. And so we've got our ground connected to ground, our 3.3 connected to VN, our RX here going to TX on the flipper, and our TX here going to RX on the flipper. Next up, we have the HC SR04 ultrasonic sensor. So we'll go into distance sensor. Pin 13 goes to trigger, pin 14 goes to echo, pin 18, your ground goes to ground, and then your 5 volts goes to 5 volts. Okay, and there it is, 9.95 inches is where that was set. Move it down to the 15-inch mark, and there's 15. Next up, we have the DHT11, which uses a GPIO pin for communication. So we'll load up the temperature up. Add a sensor, DHT11. It's going to use GPIO pin 2. So go ahead and save that. And there's the temperature of the room and the humidity. Next up is the BME 280, which uses I2C. It also has SPI if you cut the trace. And on the I2C, it's using address 76 by default. So we're going to go into the temperature sensor. Add a sensor. This is the BME 280. There's that address of 76. Perfect. And there you have it. You have the temperature, the humidity, and the pressure. So my BMP 280 is SPI mode, and it doesn't look like the software I have supports that. It supports I2C, so I'm going to skip this sensor. Next up is the BH1750 light meter, which uses I2C. So we're going to go into light meter, and there it is. If we put it near a light, you can see at the top that the lumens is getting brighter and it gets darker. Cover it with our hands, get down into little single digits. One more thing I wanted to show was the address select line. So if we pull that to 3.3, you can see it says no sensor found. So it's only looking at the default address in the app. If we go to the I2C tools and say scan and scan it, we can see the address is 23. If we connect that address line and do a scan, you can see it instead is 5C. So that's how it's changing the address, is from this pin. And then if we ground it, it should be the same as, it should still be 2.3. Yep, and there you go. So I wired up the NRF24, but unfortunately when I ran the scanner, I wasn't able to see any signals on any of the channels. A few days ago, I was seeing signals from some device, but I'm not seeing them now. So I'll have to do a video later where I connect an Arduino to one to send packets and then we can receive them. So good news, our third SPI device, the CC1101 sub-gigahertz radio, actually does work. So I'm running custom firmware here. We're going to go into sub-gigahertz. I'm going to show you the frequency analyzer so you can see that right now using the internal flipper, we're not getting much traffic. And then if I press a button on my key fob, if I'm close, we get the 314. So that's that. So now we're going to go into radio settings, which is only in custom firmware. And we're going to switch the module to external. So now we're using SPI to talk. When I run the frequency analyzer, you'll see that this antenna is picking up all kinds of 433 traffic. And then when I press a button on the key fob, we still see that at the 315 traffic. So there you go, the CC1101 using SPI. Okay, the last thing I wanted to show was the function generator hooked in on pin 16 here. And there's an application called Scope. So I'll go into Scope and go to About so you can see it. It's a flipper scope and really exciting GitHub project. It's doing analog to digital conversion. I don't know of any other examples that are doing that. So we can go ahead and say run, and you can see the square wave on here, and you can see I've set it up to 45 Hertz and it's showing 45 Hertz. If I say stop and we go in and we make, say, a 40 Hertz, and we'll switch our thing to sine wave. There's a 40 Hertz sine wave. Super cool. Sawtooth wave. There you go. So anyway, that code's doing ADC, and I believe if we can tweak it a little bit, we can have a library to do multi-channel ADC a little bit easier in our own code, which would allow us to do things like be able to read the X and Y positions of this joystick that's outputting just analog voltages. So there you have it. We went through a bunch of the sensors. I hope that this has been useful, showing you how it works. Okay, I'll make another video where we talk about the pins in more detail, but basically pin 1 is that 5 volts, which sometimes is VCC, and sometimes your circuit, when they say VCC, they want the 3.3 volts. So that's the pin 1. Then we have pins kind of 2 through 6 is being used for our SPI stuff. We see 13 and 14 used for our UARTs. 15 and 16 used for our I2C, and ground used just about everywhere. You could use a different ground pin if you'd prefer, like pin 8 or 11. But we'll go into more detail in a future video. I just really appreciate everyone's time. I hit 250 subscribers today, so totally jazzed about that. Thanks a lot. If you haven't already subscribed, I appreciate that. And if you have any questions or comments, please leave them below. Thanks a lot. I'll be making some future videos where we deep dive into each one of these sensors.